So now you see that there will be 3 bars. It means that these are the projection of your
secondary
desired criteria. But right now we don't need these 3 of them. What we are going to do,
one.
here we are going to write number of beams as 1. We are going to only apply as 1. And you can also define the orientation. Right now it says that it is parallel to y-axis. If you want to rotate it, you can simply click on the second one, x-axis. But right now, if you see our plan, our secondary beams should be parallel to y-axis. So now if you go to the window, you will see these red lines. Now they are going to draw exactly in the middle. So, in order to make sure that we really applied the releases to our beams or not, in order to see that, you can go to view in the top bar, click on set display options. When you click on this set display options, you can see that which options you want in order to make it display in your particular plan. So right now we are dealing with the object. So if you click on the object assignment, then click on the end releases and apply it to the beam. So can you see these small dots in your plan? These dots are referring to end releases, okay everyone?
What is end release?
Object assignments.
So what
Go
is
to object assignment on the top bar. See over here. View, you have to click view on the top bar. Then set display options. Then go to the top bar again called assign object assignments and click on end releases and apply.
end release?
Okay. Now these small dots are referring to end releases. Okay. Now after defining all the secondary beams and the primary beams and the columns, we have to define what? The slab system. So again you have to go to draw. Then you have to click the first option called draw floor / wall. Click on this option. And in this window, make sure that in this window you have to select the one you have defined by yourself. So as you remember, we have defined by the name called rib deck. So click on rib deck, and now simply from one joint to the opposite joint, we are going to draw it. So first click on the first. Okay, do not select this option because it is a bit I will say that complicated, so I will give you a smaller, easier one.
The point becomes
No, don't worry about it. You're going to select another option, which is much easier to understand. Go to draw again, then draw floor, and click on the second option called draw rectangular floor. Okay? Click on the second option. Again, you are going to select the rib deck property, the one you have defined. So first, click on the first point and do not release your mouse button and simply click on the opposite joint. Here you have defined your rib deck system, okay?
Can't we just from here to here? To remove that? Wait, what happens if we just... No, never mind. This is cheating, man. This is cheating. Don't look at my project.
That even your section property is wrong.
That's how it looks.
Provided no end releases.
This is a long process. It's one floor now, the other floor.
Apply those end releases.
Just the beginning.
Oh, how did we make the secondary?
Okay guys, see here, I wrote this many times.
Select copy.
If you forget, and I showed you over here as well, if you forget to define those end releases, you are going to select on the beam, go to assign, then go to frame, and then click on releases / partial fixity, and then you have to click moment release and click where you are going to provide this moment release, which is, it means that start and end, sorry. So click on apply, and then you can see all these joints. Understood? Okay. Now you have to apply throughout it. Now we are going to draw all these particular slabs. So as you know that if you see that all these dimensions are symmetrical, simply we can replicate them, right? So how you can replicate them? Click on the first slab, go to edit, and there is one option called replicate. Click on replicate, and since we are going to replicate it in x-axis, so let us say that 3 meters. Type 3 meters in your dx increment data and apply it, and it will simply draw it over there. Again, I am going to select these two. Let us not select two, it will become a bit trickier. So click on the second slab, go to replicate, or simply use the shortcut called Ctrl R, and again we are going to replicate it 3 meters again. But this time, if you see that we have symmetrical axis system, so how many slabs you are going to replicate? 2, right? Because 2 are left to draw. Everyone got this point or not? If not, I can show this again. Yes. Okay. So right now I am going to replicate the first slab. Click on the first slab. Go to edit, click replicate, and right now since we are going to draw these slabs over here, so it means that we are going to replicate in x-axis, right? So what you are going to simply do is, you are going to type 3 over here, okay? If you see that in the other part of the grid system, if the dimensions are symmetrical, so you can increase the number of replicates. So it means that we are going to replicate it 3 times, 1, 2 and 3. So simply you can type 3 over here. And apply it. Now you see that instead of drawing 1 by 1, you have to click the 2 options. Okay, now click on the replicate. Click. Yeah. No.
It's like that, have to make it.
Just put 2 over there.
Automatic will be small anyway, so don't need to.
And apply. Okay.
That makes a difference.
Now we are going to send the same procedure, but this time in y-axis. So let us select all these beams, all these slabs, sorry. Select all the slabs, not beams, slabs. Okay? If you select the beams, and again it will replicate, which means that it will override on the existing beam. It means that there are 2 beams at the same time, okay? Which will be an error. Okay? So select these 4 slabs, Ctrl plus R, or go to the replicate. Now this time you have to make x-axis as 0 and y-axis you have to write -8 this time. Why -8? because you are going to replicate downwards. If you are going to replicate upwards, you have to write positive 8. But this time it should be negative 8, negative 8 meters. Same case for here. If you are going to replicate this slab on the right hand side, which means that this is plus x-axis, you are going to write plus 3 meters. But for example, you have drawn this slab, but you want to replicate on the left hand side, it means minus 3 meters. Okay? So write minus 8 over here, and we are going to replicate only one time, otherwise it will go beyond the grid system. So click on apply and see, here is your all the particular slab material. Understood? 1 and minus 8 for the. Okay, now we have defined our story 1 data. What you are going to do next is that you are also going to draw for the same stories. Okay? Either you can use the same approach, but since we have this good option for replicate, this time select everything from top to bottom. Select all these things. Select all these things one time, okay? And replicate it. This time you are not, first of all, make sure that everything is 0 in the linear option. This time you are going to replicate in story. So go to the story mode over here and be careful here. Please everyone see over here. You are already working on story 1, right? You have completed your work on story 1. This time, if you are going to replicate it, you are only going to select story 2 and story 3. So, select story 2 and 3. Everyone selected? Don't forget about the linear right now. Because right now we are working on the story. Okay?
Around 3 to 4.
And simply click on apply, and if you see in the 3D mode, all the properties, all the same section, everything is same. Now this time what we are going to do before applying the loads, or it's up to you. Let us first apply the load. So in order to apply the loads, since we are not designing it like more precisely. As you know that we design our roof lightly, right? We have small, lower loads at the roof level, story 3. But this time we have, like let us say, apply these loads throughout the structure, okay? What you are going to do over here? First of all, if you want to apply the same loads throughout the structure, can you see this option at the bottom right corner? If you click on this one, select all stories. Click on this option, select all stories over here, okay? When you select this option, be careful. Initially it was single story. It means that everything I am going to define, it is only going to assign for that particular story. But this time, if I select this all stories option, it means that it is going to define whatever I am going to define at that particular story, okay? Throughout the structure. So let us first select the slab. We are going to apply the slab loads. So select these slabs over here. So after selecting these slabs, what we are going to do? Go to assign, then click on shell loads. Go to assign, click on shell loads. Shell load, everyone over here. Go to assign, click on shell loads, and since we are going to apply uniform load, click on uniform. So let us apply
1.5.
1.5. Be careful here. What I see a common mistake in project, that when you are going to do the manual design, you are also calculating the self weight of the slabs, right? But this time, the self weight of the slab will be calculated by E times. So only apply the finishing loads or the services loads, okay? Otherwise, you are going to define 2 times the load what you are defining over here, okay? I will repeat this again. In your project, you are only going to define these loads as finishing or services load, whatever the load apart from the self weight of the deck or precast, it's up to you. So the only one, for example, only the one you have calculated, okay, apart from the slab load. So for this case, let us apply 1.5, and the direction is gravity, right? Otherwise, you can select local 3, which is in Z direction. But if you are going to select this local 3, you are going to write negative 1.5. Okay? Downwards. But gravity, stick with the gravity, okay? You are not interested at all?
No, because I wasn't here like that. I just fell from the beginning.
So, and again, the type of the load is very important. So right now we are working with that load. So click on apply. Now it has applied all throughout it. There is one more thing. Now we are going to select these slabs again. Either you can select them again one by one, or simply use one shortcut, or which is Control plus J.
J.
It will select J. J for jar. Control plus J, it will select the previous selection. Okay? So if I use this shortcut, Control plus J, can you see that it has a, is it applying? Okay. Because right now we are dealing with the slab loads. So if you use this shortcut called Control plus J, it will select the previous selection. Okay. Now you are going again. You have to go to Assign, Shell Loads, Uniform. This time you are going to apply live load. So let us apply 4 kilonewtons per meter cube, meter square. Sorry. Direction is gravity again, and click on apply. Now these loads are being applied throughout the structure, okay, on all stories. In order to make sure that is this load being applied, go to plan, click the plan option in the bar over here. So let us go to the story 3. Click OK. Everyone? So let us go to the story 3. And if you right click on the slab, then go to the loads, it will show you that which loads have you applied. Story 3. Right click and go to the loads. What is it showing? Why it is showing different on my computer and over there? Let us do it again. Yes. If you see here, if you right click on the slab, click on loads, it will show you that which loads are being applied. So the red load is applied 1.5 kilonewtons per meter square, and the light load has 4. So it's okay for us. Now we are going to apply what? Wall loads. The wind load is automatically calculated. Either you can automatically define by the standard, or you can apply by yourself as a pressure load. So let us select all the outer beams, because we are going to provide in the 3D view that while I am selecting the outer beams, it is also showing in 3D view that it is also selecting for the other two stories as well, right? Now, in order to apply the wall loads, go to assign again. This time you are going to apply the frame loads. And in frame loads, you are going to click on distributed. So since you have uniform load, type at the bottom condition as, let us make it 2.5 millimeters per meter square. But you have to calculate for your project, right? You have to take the perimeter of that particular area and then apply this. Because first of all, you have to see that what is the length of the beam, and but first, then you are going to see that what is the unit weight of the block you are using, how many blocks you need for this particular length, and what is the total height, and calculate it accordingly and convert it into millimeters per meter. Okay, you know all this stuff. It's basic.
Oh yeah, sure.
So let us apply 2.5 and click apply. Now, in order to see these applied load, change the view to 3D. Or okay, not 3D. Go to elevation view, and let us go to the first grid system.
What?
Elevation and grid A. Click on grid A. Click apply and OK. So right now you should see that all these uniform loads should be over there for the outer ones. So now you have applied all the particular loads. Now before designing, before analyzing, we have to apply the diaphragms as well. So first of all, go to story 1 first. Everyone go to story 1. Go to plan and click on story 1. And okay. So, if you go to this story 1, I will first suggest you go to display and click on undeformed shape. Okay, now after clicking undeformed shape, now what you are going to do here, because since you are going to define the diaphragms for the individual stories, you have to change these all stories to single story, right? So select that option. Select one story. And this time what you are going to do, you are again going to select all these members. So after selecting these members, you are going to assign. Go to joint, the first option, and click on diaphragms.
D1.
No. See here. Go to assign, join, and click the third option called diaphragms. So which diaphragm we are going to apply? D1. So select D1 and apply it on your story one. There is one more benefit of that. After applying this diaphragm, it will also show you that what is the center of mass for this particular story. So it means that this red dot you see over here is the center of mass or center of rigidity of that particular story. Okay? Now go to the second story, go to the plan, select story 2, okay. Again you are going to select all these members. Again, you are going to assign, follow the same step. Assign joint diaphragm. This time D2, apply. And again, the center of rigidity is at 6 meters from x-axis and 8 meters from y-axis.
Sir, mine is not in the middle.
Not in the middle.
No.
What happened?
This one's not for your slab, by the way.
I think there's something wrong with this slab.
You have to draw this slab. If your plan is unsymmetrical, it will not be at the middle, okay? It will be somewhere else. So right now click on story 3. Again select all the members. Go to assign, join, diaphragms, and this time the last one, D3, and apply. So right now you should have applied all these 3 diaphragms, okay? Everyone? Applied all of you? Okay? Now what we are going to do, we are going to analyze our structures.
This will be interesting.
The first one is that when you are going to apply a lateral load,
It's gonna fall
each
off.
story, if you are not going to
What's
define these rigid diaphragms, each story will behave as individual elements, small elements, okay? If you apply this diaphragm, each element for the story will behave as a single object, okay, and rigid. The second benefit is that you can see that where is the center of rigidity for each story. Okay?
But we select the whole story rigid from the later view of the story.
Yes, this is what we want.
Yes, this is for like do it again.
No, that one was the property. This time is assigning of those diaphragms. Assignment. We have to assign something. Okay, now we are going to analyze. So, first of all, before analyzing our structure, we have to check our structure. Like, is there any overlapping of the members or not? Okay?
Okay, we'll do it again.
So, let us go to analyze.
Now, see, now it will be hard to find.
And
Let's check.
there is one option called check model. And in this window, you have to select all of them except the last one, which says that frame or extend. If there is any problem, we are going to do it by ourselves. Okay. So uncheck the last option, which is the frame or extend. Click OK, and it will analyze it. If there is nothing, it will show you that model has been checked. No warning messages are generated. Everyone got this message?
No.
Except this guy.
It's because of that one slab.
You have to show you. Okay? And the best benefit is that if it gives you the warning of the particular object, it will also gives the unique name. For example, let's say that for the center column, you remember it was 10, right? Let's say that you by mistake overlap. It will give you 10 and 11 are overlapping each other. So you can select from the 11 and you can simply delete it without disturbing the original one. Understood? Okay, now we see that our model is okay. We can simply analyze it. How we can analyze it? Go to analyze again, and this time you are going to run your analysis. Click on run analysis. So first of all, again, I forgot to mention you have to save your. No, it's okay. You have to save your project.
Whoa.
Always after every important.
Look at this slab.
That makes
I
a
thought
huge
that
difference. Look
it
at
is
this.
slab
on
can
the
you-
autosave
how do
board,
you-
because
how
in
can
the
I-
beginning I
It's
said
effective
let
also.
us
All the
review
storage
our
checked.
previous tutorial. Okay, so no worries.
I'm not gonna save this, I'll do this by myself again.
So let us write it as.
How do you
I will
like move
suggest
it
you
around?
One more thing.
Oh wait.
Do not save these files on your desktop. Always make a new folder. Because why I am saying this, it will generate hundreds of files. Okay? One main file and the other ones, the saved files and properties files, everything. Otherwise, even if you delete one file, your model is corrupted. Okay.
Can I save running the
Just click on this save button, it will save it. Okay, so this is tutorial 3. Tutorial 3. This is group 1. Okay, save. So it will save the analysis. Now it is running the analysis. So right now on your right hand side, you see that it is the deformed shape. So let us see that what is the deformed shape in elevation plan. So click on this window for the elevation. Go to the and make it 3D view. Let's first make it 3D. And deformed shape. What happened? Okay, if you want to see the deformed shape, go to display, click on deformed shape, and it will also show you that which kind of combination you want to see for the what? For the deflection, right? Anyone remember which kind of load we are using for the deformed shapes? Load, live load, right? So let us see for that condition. So in order to check for the live load, you have to select the live and apply it. So this time it is going to give you the deflection shape. And by the way, if you want to see that, what is the maximum deflection occurred in your, guys please focus over here. What is the maximum deflection which is occurring in your structure? It will show you over here, which is minus 20, approximately 25 millimeters. Okay? Why I said millimeters? If you recall the first ETAP section, I showed you all the units in introduction. In the introduction, it was in millimeters. So now after seeing this thing, let us see that how the moment diagram is like. So go to display, click on forces or stress diagrams, then click the second option called frame forces. And as you know that here you can see, here you can check that which combinations you want. Okay? Sorry? No selection. I will tell you. So let us say that what are the moments due to everyone is on this stage or not? Everyone. Guys, go to analyze. Go to display. Click on forces / stress diagrams. Then go select frame forces. Click on it, and here is the thing. Either you can see the moment diagram with respect to each load, for example, dead load, live load, whatever it is, or if you want to see for the particular combination for the analysis. If you want to see for the individual case, you can select the case, whatever the load type is, and if you want to see for the combination case, click on the combo and you can select any combination and analyze it accordingly. So let us see for the dead case. Select the moment 3-3. Why moment 3-3? Anyone has answer? Z-axis, right? So apply it over here. And here you can see the moment diagram. Let us go and see what is for the elevation case. Go to elevation and select elevation A. Now here you see that it starts from 0 and ends at 0. Okay? If you see for individual beam, simply right click on the individual beam, and here you can see all the parameters you want to see, like what is the shear force, what is the moment, and what is the deflection.
Right click.
Right click on the particular beam. Okay? You got it?
I didn't do this check.
Close this one, close this one. Right. Go to the elevation. Okay. Right. Okay. You're working on this window. Okay, go to this window. Right click on the beam.
Yeah, that's up to this.
Right click.
I got
So after clicking it on the right, you can see that here, be careful. In the live load, I mentioned that the maximum deflection was 25, right? This deflection is basically for dead load. Okay? So now I show you how now simply start designing our case. Since you are using the composite slab system, go to design and select the third option called composite beam design. Everyone, make it 3D view please. 3D view. Now this is developing as 3D. What you are doing?
I tried to change this one, so let's start again.
Okay. Now go to design at the top bar. Select the composite, because since we are using grid decks and grid decks are composite beam, right? Go to composite beam design over there. And first of all, you have to see the preferences. Click on preferences. All these are by default, okay? Do not change anything, okay, over here. So go to design, composite beam design, and start design check. So here is the thing, guys, everyone please check over here. Okay, now here what you see here, first of all, when you check the design, first of all I will tell you what is the meaning of these color scheme. If the beams are shown in, guys please first look over here, then follow. This color scheme has some meaning, it is showing you the steel ratios, okay? If your beam is shown as red color, it means that it is not acceptable. Okay, the design is not acceptable at all. It means that the ratio is more than 1 or equal to 1. Our steel ratio should be less than 1. If your design beam is, for example, in these 3 combinations, or I will say these 2 combinations, or let's say these 3, green, yellow and purple, it means that it is economical design. This is very safe. Okay, if it shows the ratio as in between 0 and 0.5, it is very safe. It means that you have much bigger section. You can change it later, yes.
Should all the frames be the same color?
No, it will not be. Okay, but all of them should satisfy. Okay. So it means that if your section is below ratio 1, your design satisfies. If your section is in between 0.5 and 1, it means that it is economical design. This yellow is more preferred because it is in between these 2 conditions, right? If it is blue color,